Massive cloud on collision course with the Milky Way, presented by Science at NASA. In 1963, an astronomy student named Gail Smith, working at an observatory in the Netherlands, discovered something odd. A massive cloud of gas orbiting the Milky Way galaxy. Smith's cloud contained enough gas to make 2 million stars, the size of our own sun, and it was moving through space at 700,000 miles per hour. For the next 40-plus years, the cloud remained a curiosity, one of a growing number of so-called high-velocity clouds circling the Milky Way. Interesting, but not sensational. Then something changed. In the mid-2000s, radio astronomer Jay Lockman and colleagues took a closer look at Smith's cloud using the Green Bank Radio Telescope in West Virginia, and they were able to calculate the cloud's orbit. Smith's cloud, it turns out, is on a collision course with the Milky Way. 30 million years from now, give or take a few million years, it will crash into the Perseus arm of our galaxy. The impact will compress clouds of gas in that spiral arm, causing a brilliant burst of star formation. There's no real danger to the Milky Way. Smith's cloud is minuscule compared to the gigantic spiral of stars that make up the backbone of our galaxy. But the coming collision has sharply increased interest in Smith's cloud. Andrew Fox of the Space Telescope Science Institute says, "We don't fully understand the Smith's cloud's origin. There are two leading theories. One is that it was blown out of the Milky Way, perhaps by a cluster of supernova explosions. The other is that the Smith cloud is an extragalactic object that has been captured by the Milky Way." To investigate these theories, Fox and colleagues recently peered into the cloud using the Hubble Space Telescope's Cosmic Origin Spectrograph. One of the elements they found was sulfur, absorbing ultraviolet light from the bright cores of 3 galaxies far beyond the cloud. By analyzing the amount of light Smith's cloud absorbs, the astronomers were able to measure the abundance of sulfur in the cloud. Fox says the abundance of sulfur in Smith's cloud is similar to the abundance of sulfur in the outer disk of our own Milky Way. This means we have a family relationship. He says the cloud appears to have been ejected from within the Milky Way and is now falling back. The cloud is fragmenting and evaporating as it plows through a halo of diffuse gas surrounding our galaxy. It's basically falling apart. This means that not all of the material in Smith's cloud will survive to form new stars. But if it does survive, or some part of it does, it should produce an impressive burst of star formation. While Fox's work has cleared up some of the mystery of the Smith cloud, many questions remain. What calamitous event could have catapulted it from the Milky Way's disk, and how did it remain intact? These are questions for future research. 30 million years to impact. The clock is ticking. For updates about the Smith cloud and other impactful science news, stay tuned to science.nasa.gov.